Now let's go ahead and talk about the need for switches. Network devices have three different methods of sending messages across a local area network. These methods are called unicast, multicast, and broadcast. When using the unicast method, only a specific device is addressed, and we can name this communication one-on-one. Multicast is one-on-several communication. With multicast, we address a specific group of devices. Broadcast is a one-on-everything type of communication method. In this case, you want the whole network to know something, and you send that information in a broadcast message. Let's not go too far into history, however, but there is one piece of network hardware that's worth mentioning, and that is called a hub. A hub was once a very useful part of a network structure. It was a central point network device, to which you could connect a group of devices and enable them to communicate amongst each other. Imagine if you have two classrooms filled with PCs, and you want to enable the PCs in those two classrooms to communicate with each other. You could get two hubs, but one in each classroom, and connect them with each other. All you have to do after that is connect the PCs into the hubs, and the communication would be enabled. Hubs were a simple, inexpensive solution when it came to networking in those times. There was only one problem with them, though. Hubs broadcasted everything they received out all ports, except the original incoming port. They worked in half-duplex mode only, which meant that a port on a hub could only send or receive at any one time. Because of this, collisions were an enormous problem. Collisions can happen when two or more devices send messages at the same time. Because on half-duplex communication, those devices cannot receive messages, which means in that case that there are inbound messages for them while they are trying to transmit, and they wouldn't be able to receive those inbound messages, causing those messages to be lost. Parts of the network where these collisions can occur are called collision domains. When networks grew in size, it quickly became obvious that hubs were not sufficient anymore. Bigger the network, the more collisions. The more collisions, the more resent messages. And the more resent messages, the more possible collisions again. That is why hubs nowadays are mostly obsolete, and switches became the cornerstones of every network. Switches were capable of unicast, multicast, and broadcast, since they work on OSI Layer 2, while hubs worked on Layer 1. Switches use MAC addresses to switch messages accordingly, and because of that, they limit the collision domains. Every switch stores MAC addresses it encounters in its lifespan in the internal MAC table. Switches create and maintain table entries so they can refer to them in the future and decide to switch certain frames out certain ports based on that information. And they also limit the collision domain. But how does a switch process a unicast frame? When a switch receives a frame, it looks at the destination MAC address of the frame. If the destination address is mapped in the MAC table to the same port that the frame was received on, the frame will be dropped. This is called filtering. If the destination address will correspond to a different port, it will be forwarded out that port. If the switch does not have a destination MAC address in its table, it will transmit the frame out all ports except the original receiving port, and we call this flooding.